I'm Leonie Watson. I'm an accessibility engineer with the Paciello Group. I'm also accessibility lead for the UK government. And amongst other things, I work with the W3C on things like ARIA, HTML, and SVG. Sometimes in these kinds of conferences, it can be difficult to ask questions. So I think my Twitter nick is up on the screen. It's Leonie Watson. Ping me any questions you've got or come and find me afterwards. And I'll be tweeting out some links after I catch my breath when this talk is over as well. So what am I going to be talking about? Well, simply how you can use ARIA, accessible rich internet applications, to make custom interfaces built with HTML, SVG, and even web components more accessible, but without compromising on the functionality that you want to provide. Before I do that, though, there's something I want to get out of the way, and that's the fact that accessibility has something of a reputation problem. Quite often people think of accessibility and they think it's going to stifle their innovation or their creativity, or they get into a bit of a panic because it all seems a bit fluffy or a bit intangible, unfamiliar, and perhaps a little bit scary. It's really none of those things, and we're going to try and walk through some stuff today that will really prove that it's not, as a friend of mine is wont to say, rocket surgery. People, when they think about accessibility, also think about legislation, about checklists, about being sued, about being, having to conform with things. And although those things have their place, they're not really things that rock my world. I don't know about you. But something that does is this concept.
Slide 3, slide.
Oops.
Enter. Slide 2, code like you like.
Accessibility for me is thinking about the time and effort that we put into developing things, whether it's something that's just seized us in a moment of creation or innovation, or when we're just going through the motions to get a job completed. The one thing that we all have in common when we build these things is that we want people to use them. Actually, we want a lot of people to use them, and we want people to enjoy using the things that we build. So accessibility is recognizing that we're not coding like it's 1999 anymore. It's not the days when most people used a mouse to access content and people with disabilities probably used a keyboard or a related device. But we're in an age now when people use touch, speech, mice and keyboards to interact with content. And they also consume content in different ways, by looking at it, by listening to it, even by feeling it through haptics and taptic feedback. And there really is no way to distinguish the people who do have disabilities from those who don't within the audience. The only thing we can guarantee is that there is some combination of those input and output models are going to be used by pretty much everybody who uses your products. So if you take one thing away from this talk today, please let it be that accessibility isn't just about legislation and guidelines and constraints and obstacles. It's just about giving a damn about the things that you code and giving a damn about the people that are going to be using the things that you build.
Slide 3, accessibility mechanics.
So let's start off with a little bit of the accessibility mechanics. What happens when you put some code together and it gets loaded up into the browser? How do things work from there to the user and the interface?
Slide 4, DOM tree.
Something you almost certainly know is that when you put some code into the browser creates the document object model, the DOM tree, a hierarchical representation of all the content.
Slide 5,
what you might not know is that the browser also creates an accessibility tree. It's another hierarchical representation of the content and the nodes on the page, but this time the information is there specifically to be used by assistive technologies. That might be a screen reader that translates what's on screen into synthetic speech, screen magnification tool, or a speech recognition tool that someone's using to issue voice commands to their computer. And there's all kinds of information in the browser's accessibility tree.
Slide 6, role bullet ID.
One thing you'll find in the accessibility tree is information about the role of each object in the interface. All HTML elements have what we call implicit roles, which means the browser automatically knows what kind of HTML element it's dealing with. In the example on screen, we've got a checkbox, and it's the input with the type of checkbox that tells the browser that that particular element has a role of checkbox. And that information is made available through the accessibility tree. So, for example, when a screen reader user hits the resulting piece of code, their screen reader just says, this is a checkbox. So that applies to all roles in HTML, whatever it may be, a paragraph, a text area, a link, an image, whatever. They've all got implicit roles. So as developers, you don't have to add them in. They're just there already.
Slide 7, state, bold ID.
The other thing, or another thing, is the state of an object. So here we've got the checked attribute on the input, and that just says to the browser and the DOM and also to the accessibility tree that this particular checkbox is checked. Visually, that has a representation, but also for a screen reader or other assistive technology user, that same information is also made available by the browser.
Slide 8, properties.
Lastly, there are all sorts of properties about different elements when you code in HTML, and the most common of them is an element's accessible name. An accessible name is how you differentiate one thing of a particular type on a page from another. So in this instance, how do we differentiate this checkbox from any of the others that might be on the same page? And in this case, we're using the label attribute and hooking it up to the input to use the text string inside the label as the accessible name. So now a speech recognition user looking at this checkbox can say, check the tequila checkbox and call it by name, and the tool will go ahead and carry out the interaction. So there's all kinds of information available from the browser to assistive technologies.
Slide 9, accessibility.
How does this all work? There are APIs on every single platform, Windows, Linux, OS X, iOS, Android. And these APIs allow you to query the information in the accessibility tree in the browser.
Slide 10, accessibility stack, assistive technology.
So we end up with a stack. The APIs actually exist at the operating system level. So an assistive technology can query for information in the interface at the operating system level. It can do the same in terms of the applications within the operating system, or it can do the same to render content within an application like a browser. And what happens is that, for example, if there's a checkbox in any of those interfaces, the assistive technology treats them in exactly the same way. It doesn't distinguish between a checkbox in a software interface or a checkbox in a web interface. The information and the accessibility information is all exposed in exactly the same way.
Slide 11, JavaScript.
So the key question is, can we interact and do things with these APIs with JavaScript?
Yeah.
Unfortunately, not yet. There is work being done, very early days work, to look at ways to maybe make it possible for JavaScript to be used to interact with these APIs. But in the meantime, this is where ARIA comes in. I said earlier, it stands for Accessible Rich Internet Applications. Version 1 is available as a current specification from the W3C. We're starting work on 1.1 and already looking ahead, actually, to version 2. And what ARIA is a set of attributes that you can apply to markup languages that let you manipulate or change the information that's exposed through the browser's accessibility tree.
Slide 13, HTML disclosure.
So let's just walk through an example that will start to demonstrate how you can pull all of these things together to start making stuff work in a more accessible fashion.
Slide 14, skeleton HTML.
We're just going to start with a really custom disclosure widget. Now, yes, there is the details and summary elements, but they're so poorly supported in browsers that they're really not worth bothering with. And besides which, for the purposes of this talk, we just want to start from something really basic. So we're going to start with just a span that's going to represent the controlling element for the disclosure widget and a div that's going to contain the content to be disclosed.
Slide 15, using a mouse.
So if we imagine for a minute that we've just added in some scripting, some functionality, some styling, and all other bits and pieces, this is how it's going to work for a mouse user.
Code.png.
So
started
everything works pretty much as you might expect. But
Slide
things
16,
get very different when you use a screen reader or a keyboard. The first problem actually is that if you are a keyboard user, forget the screen reader, you can't actually use this at all. It's a very pretty looking button, but a span is not an interactive element, so you can't focus on it with a keyboard. If you try it with a screen reader, it is actually possible to focus on it because screen readers can pull off some interesting tricks to get around some of the keyboard accessibility issues. But this is what happens when you do.
Tequila.
That's it. Just the one word. There's nothing that tells the screen reader user that this can be interacted with, that it's a button, that it's got any kind of functionality. It's just being treated as plain text. And the reason is that span is a semantically neutral element. Its role when it's exposed through the accessibility tree basically just says treat anything inside this span as plain text, which is exactly what's happened. So we've got to do some work to kind of match up the visuals and the functionality with the experience for screen reader users.
Slide 17, add button role.
So the first thing we're going to do is just use the ARIA role attribute, and we're going to give it a value of button. And we're going to put that on the span element. What this will do is, in the accessibility tree, it'll tell the assistive technologies to stop thinking about the span as a span, but instead to think of it as a button. It's really important to stress, though, that this doesn't change anything in the DOM. The DOM remains exactly the same. It's only the information in the accessibility tree that gets changed. The other important thing to stress is that ARIA doesn't provide behavior or functionality. It's simply about semantics. So now we've taken a step towards enabling a screen reader, at least, to recognize that this thing, this button, can be interacted with.
Slide 18, add to index, book reader.
We need to deal with the keyboard focus issue, and we're going to do that by putting the tab index attribute with a value of 0 also on the button.
Bullet.
Tab index has been around for a long time, actually, but it was expanded in ARIA 1 to allow different values, including -1 and 0. That's now been wrapped into the HTML5 spec, of course, but what a value of 0 does is place the object into the tab order based on its location in the DOM. So it's a very natural way of doing it. As a keyboard user tabs through the page, they'll just hit this button in kind of source order, exactly as they would, as though you put in there an interactive element like an actual button element.
Slide 19, add ARIA expanded.
Now we're going to add in some more ARIA, and we're going to look at state. We're going to use the ARIA expanded attribute, initially with a value of false, because we'll work on the assumption that the disclosure widget's going to be closed by default.
Bullet.
That also goes on the span button. When the button is activated, scripting wants to toggle that to true. And what that'll do is tell the screen reader the state of the disclosure widget. So if it's closed, it'll say it's collapsed, and if it's open, it'll say that it's expanded. So we're starting to build up the picture for people who can't automatically see what's happening on screen.
Slide 20, slide, SPSH favorite.
We're now going to hook up the two things. We need to create a relationship between the button and the content that it controls. So we're using ARIA controls, again, on the span, and hooking it up to the idref of the div.
Bullet.
And what this will do is when a screen reader now comes along and opens this disclosure widget, they'll be told that something has changed or there is some related content. And in the case of some screen readers, JAWS most noticeably, well, they'll be given a shortcut command to move their focus directly to the content that's changed or opened. Now, in an example like this, that's literally just going to be down the page, a short step from the control button. But if, for example, we were using this to hook up perhaps filtration on some search results where, you know, there might be a few steps or quite a lot of content between the controlling button and the changed content, having a shortcut key just to move focus really quickly there is a very useful thing to have.
Slide 21, add ARIA hidden, bullet span.
We're now going to add in ARIA hidden. What ARIA hidden does is remove the content that you apply it to completely from the accessibility tree. It's like it wasn't there at all. And we're going to chuck it in on a couple of places. We're going to put it in on the span where we're going to put a visual icon, simply because the icon is just there for sighted people, and so there's no real need for a screen reader user to know about it. And we're going to set that one to true and pretty much leave it alone for the duration. We're also going to put it on the div containing the content, and we're going to set it to true initially because the content will be hidden, and then as the scripting kicks in when the button's activated, we'll flip it over so it mirrors the state of the disclosed content.
Slide 22, add event listeners.
We then need to think a bit more about the keyboard accessibility. When you're scripting something like this, it's pretty 101. You're going to add in some mouse functionality, but you also need to think about keyboard functionality. The expected interaction with the button is that you can use either the space or the enter keys to interact with it. So we use the key down listener because we want it to return a code, so we can identify which keystrokes have been pressed when someone's actually interacting with the button.
Slide 23,
and then we take that a step further and we listen out for the two particular key codes, 13 and 32, that represent space and enter. And we basically, through the scripting, say if any other keys have been used to interact with this button, ignore them, let them go on and do their default thing. But otherwise, we want to execute the functionality of the disclosure button.
Slide 24, add functionality,
and then to do that, we're going to just use the scripting to toggle the different states of the ARIA we put in. So we're going to change the expanded, depending on the open and closed state. We're going to change the ARIA hidden state. And suddenly our disclosure widget is starting to behave a lot more like you expect.
Slide 25, add focus visuals, bullet button.
We need to do some work on the visuals. Now we've made it keyboard focusable. We need to make sure that the same visuals are being used when you tab onto it as when you mouse over on it, and we're just simply copying the visual styles for hover and using them for focus as well. So it's a really simple trick. You've already got the code, just double it up.
Slide 26, add state visuals, boot rolling period.
We're adding in the state visuals, and this is where we're going to just put in the icon and flip it around depending on the state of the disclosure widget, because if we're going to make something accessible for everybody, that really does have to include everybody, and that just makes it a bit easier on the eye to know what's going on. And what we're doing is using attribute selectors here because it keeps the HTML a little bit cleaner. It's got nothing to do with accessibility, but it just saves dotting classes around in your HTML. It also creates a symbiotic relationship between the ARIA state and the visual state, which just keeps things a bit tidier and a bit cleaner.
Slide 27, add functionality.
And then lastly, we're just hooking the styles in. So we're doubling up on the ARIA hidden and you kicking in with some CSS display none as well, which is pretty much what you'd expect to do. You might be asking why bother doing both ARIA hidden and using the CSS. It's really just a belt and braces technique. There are some edge cases where someone might not be using the style sheets for the website, but they may be using, say, a screen magnification tool. It really is a kind of an edge case, but just taking it out of the accessibility tree is just an extra reassurance that everything's going to work as you'd expect it to.
Slide 28, using a screen reader.
So now, after all that work, this is the difference it makes to someone using a screen reader.
Using a tequila button collapsed. Tequila button expanded. Use JAWS key plus Alt plus M to move to controlled element. Move to controlled element. Makes me happy ...
So, tequila makes me happy. Who knew? But there are, as you can see, the button still behaves, looks exactly as it did right back in that first mouse example. So nothing on the face of it has been changed or compromised in the way we wanted it to behave or the way we wanted it to look. But the experience for someone who previously couldn't use that is now radically different. And that's really the true strength of ARIA.
Slide 29, SV.
We can also use ARIA with other markup languages. The one we're working on at the moment is SVG. SVG is a bit more tricky than HTML, though. The current version of the spec is 1.1, and it doesn't really have any native accessibility in it at the moment. So where I explained that HTML elements have implicit roles, we don't have that in SVG at the moment. It's coming in SVG2. There's a lot of work going. One of the links I'll tweet out later is a first working draft of the mappings that will explain which roles will be implicitly assigned to SVG elements in SVG2. But for now, we can still use a bit of ARIA to make some difference to SVG as we use it today. If you're using a conformance checker, though, I will warn you that sticking ARIA in your SVG right now will give it a bit of a conniption fit. But don't worry, it's not the sort of errors that really should be causing you any bother.
Slide 30, basic SVG, full SVG type.
So the first thing we can do is we'll just take a standard bit of SVG, just drawing a simple rectangle graphic on the screen. As far as the accessibility tree is concerned, there's really nothing here to deal with. In some browsers, Internet Explorer will take a potted guess and tell you that there is an image there, but other browsers don't really expose any information. So it's a bit of a black hole, in other words.
Slide 31, add ARIA left.
So we can use an ARIA attribute, ARIA labeled by, and we can hook it up to the title element of the SVG. Title in some user agents can be rendered as a tooltip when you hover it over with a mouse. What we're going to do here is, as soon as a screen reader user gives this SVG focus, the title element will get read out. We're using labeled by here because the title element is actually rendered content on the page. Another alternative approach to doing this will be to use ARIA-label, in which case you just apply that to the SVG element and give it a string instead of the idref of the title element.
Slide 32, add ARIA
then we're going to do something pretty similar, but we're going to use ARIA described by, and we're going to hook that up to the desk element. And that's going to do pretty much the same thing. It's just going to make a longer, more descriptive piece of information available to someone who can't see the image. And again, that'll automatically get read out when the screen reader focuses on the SVG.
Slide 33, add in role.
We can also add in a role. In this case, we put a role of image, IMG, on the SVG element. So now this, to all intents and purposes, will behave very much like a standard graphic when a screen reader encounters it. It'll say something like graphic, and then it'll read the title and then the description. So at least a screen reader user now has a kind of working understanding of the content that's on the page.
Slide 34, add button role.
If we turn our green rectangle picture into something a bit more interactive like a button, though, we need to do a couple of different things. We need to make it focusable, and actually the easiest way to do that is to use the SVG Anchor Xlink element. Because it's an interactive element, it provides the keyboard focusability natively. It's not very well supported, though, across browsers and screen readers. So we're also going to chuck in the tab index with a value of 0 just for belt and braces to make sure that everybody can focus on this. But then because this isn't a link, it looks like a button, we need to make it appear as a button in the accessibility tree. So we just add the role of button exactly like we did before onto the SVG element. So that's just a few kind of bits and pieces that you can do with SVG. There isn't much farther that you can take ARIA and SVG beyond this right now, but as I say, work is coming. That'll mean SVG2 has a lot more opportunity.
Slide 35, custom disclosure.
So what about web components? Kind of the new kid on the block, causing a lot of excitement. What does it mean for us in terms of accessibility? So web components is a collection of 4 different specifications, including custom elements, and we're going to focus on that for a moment.
Slide 36, registering the custom tag.
So you've got a couple of options. You can create a custom tag, something completely new, a truly sort of innovative idea where you're not really evolving it from anything that already exists in HTML. And to do that, you just simply register the element and add it to the document in fairly standard scripting style.
Slide 37.
When you come to instantiate it, you simply use your new tag name. So we've got a tequila button. This is in complement to Marcy Sutton's taco button, so if any of you were in her talk earlier, this is Tequila and Taco Button Day, I think. But what this does in the accessibility tree is pretty much nothing at all. The information is there in the DOM because we've registered the element, but the accessibility tree doesn't really recognize it. We're stuck, effectively, with the same problem we had right back at the beginning with those spans and divs. It's just treated as plain text and not much more. So,
Slide 38, add a role, period.
Here we go again. We add a role in, and we can do this in the lifecycle callback function. And again, we just need to add that role of button in.
Slide 39, add event listeners.
We need to add in the event listeners. And again, we'll use the same key down to make sure we're listening out for the right keystrokes along with the mouse. You do a whole bunch of other stuff in here as well. You'd need to add in the tab index to make it keyboard focusable. And basically, all the other ARIA bits and pieces that we looked at in the HTML example.
Slide 40, something familiar?
So if all of this is sounding terribly familiar, it really is. When I first started looking into web components, I was somehow expecting there to be something really shiny and new in terms of accessibility as well. I talked to a lot of my friends and colleagues who deal with accessibility and web components, people like Dylan Burrell, Carl Groves, Bruce Lawson, and actually the conclusion that they'd all come to, and I came to fairly shortly afterwards, is that there is absolutely nothing new in terms of web components and accessibility. It's just applying the same semantic, good common sense that we do with HTML, with SVG, or any other language. But there are things we can do to make stuff easier. Instead of creating custom tags, we can use type extensions. And that's taking your starting point as an existing HTML element, in this case, the obvious example being the button element, and using that as a prototype for the new type of button that we want to create. What this does is it means when you actually instantiate it, you're starting with the button element in the code, using is equals to indicate that you've evolved it into a tequila button. But from an accessibility point of view, all the goodness of the button element is taken from the DOM and exposed through the accessibility tree. So it's already focusable. It already listens out for the space and enter keys. All you'd need to do at this point was make sure that your visuals and your scripting matched up to create the experience you wanted. And if we were creating this as a disclosure button, you'd probably want to use some of the ARIA we looked at in the first place to add the state, like expanded and collapsed, and a controls thing. But basically, if you use type extensions, you get a lot of the hard work taken care of so that you don't have to bother, which in itself is pretty much standard HTML good advice, as you probably are all aware.
Slide 43, code like you give a tab, full name.
So I hope that now you have perhaps a different idea of what accessibility is like and how it can be added on a practical basis without really challenging the status quo of what it is you want to accomplish. So if you leave here today and feel like going out there and coding like you give a damn is a good idea, then the things to think about are accessible names, properties, focus, role, and state. And if you can think about all of those things and how people are using touch and mice and keyboard and speech input, and they're listening and feeling as well as looking at content, then you'll be out there and helping us all make the web a much better place for everybody.
Slide 44, Lady Watson.
Thank you very much. If you've got any questions.